Dr. Ranjini Parthasarathy is a professor in Department of Computer Science and Engineering. Her area of specialization is in computer architecture and computer networking. She had guided more than 5 PhD students and currently guiding 5 PhD students. She had published papers in more than 50 national and international journals. She worked in many sponsored projects and she got IBM Faculty Award for 2008.
Welcome to the UGC lecture series in computer science. We are looking at the topic of networking. In this episode, we will be looking at layered network stack models. Learning objectives for this lecture will be as follows. We will understand the concept of layering, the idea. Then we will be looking at layering and data flow. And third, we will be looking at two popular stack models, the Internet TCP/IP model and the OSI model. The Internet TCP/IP model and OSI model are two important models, so we will be looking at these two. Before we start, let us just do a quick recap of how an end-to-end data flow happens in the network. So, let us look at what is happening over here. We basically have end systems connected by means of some kind of an access network, followed by a number of routers, and then it finally reaches the end system. So, this is the basic flow of data that is happening in a network. Now, you can see that you have different types of end systems. We have mobile systems, you have desktop computers, you may have some handheld devices, all kinds of end devices would be there, and any of these end devices would be able to talk to any other end device. And if you look at the data flow, you can see that it always goes through a set of routers through various links before it reaches the network, before it reaches the end system. So, this is the basic flow of data that has to happen in a network, and we just need to see how a layered model will help in such a data flow. Okay. Now, if you look at general layers in an internetwork, this is something that we have also looked at in a previous episode. We can see that we normally have an application layer, a transport layer, a network layer, a link layer plus a MAC layer and a physical layer. At least these 5 layers we can always identify as the minimum number of layers that are required in a network. Now, before we look at why this layering is required, we will just look at an analogy. We will take an analogy of bus travel, which is something that we are all very familiar with. So, let us say for instance, you want to travel by bus. Let us just look at the series of operations that actually take place during this bus travel operation. So, what is it that we do first? We purchase the ticket. Second thing that we will be doing is you will go with your baggage. So, you load your baggage onto the bus. Say for instance, if you are traveling long distance, you make sure that all your baggage gets loaded on top of the bus. Then you get into the bus, which is boarding the bus starts, and then the bus goes through different routes and finally reaches the destination. At the destination, you can again see that it gets routed into the bus stand, it will reach the destination, then you get off the bus, which we call as unboarding, then you claim your baggage and then you pick up your baggage and then you walk out. And before you walk out, if you have any complaints to make, you again go to the ticket counter, you make the complaints and go off. So, you can see that there are a series of steps that take place both at the starting station, at the ending station, and there is a bus routing that happens in between. So, now let us just look at how this same bus travel can be organized and looked at from a different point of view. So, let us just look at what happens with respect to ticket. Now, there is always a purchase of ticket that takes place, and similarly complaints with regard to tickets can happen at the ticket counter. So, these are two operations can happen at the ticket counter. Similarly, baggage loading and baggage unloading. You normally have a set of people who will be helping you with loading the baggage, who will get on top of the bus and put it on top of the bus, and similarly take it from the bus, top of the bus and give it to you. So, one is at the sending end, one is at the receiving end. So, you have loading and unloading that happens as the second unit of work that needs to be done. Third, if you look at, you are getting into the bus and you are getting off the bus. So, it is basically you are getting into the bus and off the bus. Bus starts, bus reaches destination, and in between the bus gets routed through different routes, through different roads that it takes, and it finally reaches the destination. So, now we can look at each layer as implementing a particular service. So, now if each layer implements a service, how does it do that? It has its own internal layer actions. So, when a ticket is purchased, so that ticket has some information in it. So, when a complaint is lodged at the other end, you will be able to understand that it is with respect to this particular ticket that this information, this complaint is being lodged. So, there is some kind of internal information, internal layer actions which are done at each of these layers, and in order to do each of that layer services, it relies on the services that are provided by the layer below. For instance, if you just purchase a ticket, if you do not know that you can take that ticket and go and board a bus, there will be no use of having that ticket. So, what you do is you purchase the ticket, pick up your baggage, go and get into the bus, then the bus starts, and then the bus gets routed and finally reaches the destination. So now if you have this kind of a view, let's look at it a little more differently now. Let's look at how this same functionality at different layers gets implemented at different places. Okay, for instance, just take the departing bus station. If you take the departing bus station, we have ticket purchase, baggage check, gets getting loaded at the gates. That is, you are entering the bus starts and bus routing. All these things are things which take place at the departing bus station. So similarly, at the arriving bus station, you have the bus reaching the place, then you are getting off the bus, then you claim your baggage, and then you make a ticket complaint. So this is at the arriving station. At the intermediate bus terminals, the buses are getting routed. For instance, if you are going from one station to another station, there are many intermediate terminals that you may visit. Typically what happens at the terminal is that the bus will be probably routed to go from one place to another place. So this is you can look at this as a distribution of the different functionalities that is happening in a network, in a bus travel. So the same thing is what we are going to look at with respect to a network. So the same thing if you look at from a network point of view. So let us look at the distribution of network layers in a network. So now the layers in a network. So let's look at what's happening at the end system. At the end systems, you have the application layer, the transport layer, network layer, link layer, and the physical layer. So data will typically go down from the application layer all the way to the physical layer and then traverse through the network. At the intermediate routers, you may not have all the 5 layers, but you may just have the functionality which is required for doing that job. That is, you have the physical layer, the link layer, and the network layer. Say only 3 layers are required over here. And then at the end systems again, where the data is to be received, you again have the same 5 layers: physical layer, link layer, network layer, transport layer, and application layer. So you can see how the data flows across the network through the various layers. So now let's look at this layering and how data actually is dealt with in this layering process. Basically, we talk about something called encapsulation and decapsulation. So let's understand what we mean by encapsulation and decapsulation. What happens actually in terms of encapsulation is that each layer takes data from the above layer. That is, it has some data that it has to deal with. So it has to encapsulate it. It has to put it in a capsule, or it has to form a packet out of it. So it just takes the data from the above, adds header information to create the new data unit. This process is referred to as encapsulation, and then it passes this new data unit to the layer below. In decapsulation, the reverse of this whole thing will happen, which is that is at the receiving end, you will receive data from the layer below, you will remove the header information from that, and then you pass it to the layer above. So this is what we call as encapsulation and decapsulation. So every layer, when it is dealing with data, it basically does these two things. It encapsulates the data at one end and decapsulates at the other end. So let's look at how this encapsulation and decapsulation actually takes place. So let's look at this now. So user is giving some data. We are looking now at the source side. User is giving some data. Let me call the data as M. Now this M data is passed on, is given to the application layer. Now the application layer itself adds some header over here. Okay, HA is the header which is added by the application. Now this process of adding header by the application layer to this message M is nothing but the job of encapsulation, which is done at the application layer. Now this M plus HA, this whole thing is passed on to the transport layer. And what is it the transport layer does? It uses the M plus HA as the data that it gets and adds an additional header HT to that, and passes this whole thing now to the network layer. Network layer similarly adds its own header, which is HN, and then passes that to the link layer. Link layer adds its header, which is HL. So you have, when it comes down to the physical layer, you have HL plus HN plus HT plus HA plus the M, the message which was sent by the actual source. To this, the physical layer also may add its own header, which we call as HP, and what is actually transmitted along the physical network, you will see, is this whole lot of bits, that is message bits plus the bits that are added by each of the layers, by the physical layer, by the link layer, by the network layer, by the transport layer, and the application layer. So these bits traverse along the network and reach the end machine. When they reach the end station, let's look at what happens here. The physical layer is not concerned with any other information other than the information that was put by the physical layer at the other end. So all it will do is, it will extract this HP alone, this header which was the physical layer header alone, which was put in by the layer on the other side, removes that header, and based on that header information does whatever operation is to be done and passes the rest of the data to the link layer. So if you look at the link layer, now what link layer gets is what was actually sent by the link layer on the other side. That is, you have HL plus HN plus whatever. Now what the link layer will do similarly is remove this HL, do whatever processing is required, and pass the rest of the data to the network layer. So network layer gets HN plus HT plus HA plus M. Now again, what will the network layer do? It will take out the network layer information and pass the rest of the information back to the transport layer. So if you look at what the transport layer gets, it basically gets what the transport layer handled on the other side. Okay, so whatever was information was put by the transport layer here is what is handled by the transport layer on this side. So you can say that each layer needs to only understand the information that is passed on by the peer layer which at the other side. So now the transport layer will remove this HT and pass the data to HA. The application will remove the HA and pass, and whatever message is to be passed will be passed on to the user. So you can see how the data is actually handled on the using this encapsulation and decapsulation process. So you can see that adding of these headers here is encapsulation, removal of the headers here is the decapsulation process. So now let's look at again let's get back to the same picture that we had earlier and see what will actually happen with the headers. So now look at what will happen over here. So data will be given to the application layer. So application layer will add its header, pass on the data to the transport layer. Transport layer will add its header, give it to the network layer. Network layer would add its header, give it to the link layer, and then that will add its header and give it to the physical layer. Physical layer now will actually transmit all these bits and it will come to this physical layer which is there at the router. So now at the physical layer at the router, what will this do? This will remove the physical layer information here and pass it to the link layer here. The link layer will remove the link layer information, pass it to the network layer. Using that network layer header, the network will decide how this packet is to be or this data is to be sent, how it is to be routed, and will determine where it is supposed to be routed. And it determines where it is supposed to be routed at this network layer. It is doing its network layer functionality. Once it is finished with this network layer functionality, it will pass the data to the network, to the link layer. Now the link layer now will add its header, the link layer header, and pass it to the physical layer header. Now look at what happens here. We have actually link layer doing two types of operation within the single device. At the router, you can see that on one side it is doing a decapsulation process, and again on the other side it is doing an encapsulation process. It may do both, it will do both decapsulation and encapsulation because it is dealing with two different physical links. Here there is a different physical link that is dealing with, for which it may need to do a different kind of encapsulation, and here it has to deal with a different kind of physical link, so it may need to do a different kind of header information that has to be given over here. So this link layer here will do a new encapsulation and pass it on to this physical layer. Physical layer again will do the encapsulation and it will go along the physical whatever wire or wireless medium that is there and go to the physical layer over here. So here at the end station you can see that the entire process of decapsulation takes place. Physical layer will remove its header, give it to the link layer, which removes its header, gives to the network layer. That will remove its header and give it to the transport layer. Transport layer on its side will remove it and give it to the application layer. Okay, so this is how the physical flow of data takes place. Now we can also understand how the logical flow of data takes place. What do we mean by logical flow of data? You can see that transport layer, whatever information is given by the transport layer, is only handled by the transport layers on the other side. Note that in between, at any of the layers, at any of the nodes which are there in between, you only have these three layers: physical layer, link layer, and network layer. So none of the transport layer information is tampered with by any of these layers in between, by any of the devices which are there in between. So between the transport layer on this side and the transport layer on this side, you can say that there is a logical connection that is established, and logically data flows from one application to another application through this transport layer. So physical flow, it will go through all the layers. Logically we need to understand that it just goes from this transport layer through this transport layer and then it reaches the application. So we will take a small break with this and come back and continue with the stack models in the next session. Welcome back after the break. Before the break we were just looking at how data flows in a layered stack approach, in a layered stack model. So now what we are going to look at is two different stack models which are commonly used in networks. In fact, one of them is very commonly used and the other is a standard which was proposed right at the beginning. So the two stack models that we are going to look at are the Internet TCP/IP 5-layer model and the OSI 7-layer model. Of these two models, the TCP/IP model is the most commonly used network model which is in vogue today. The OSI 7-layer model was the one which was originally proposed, so we will take a look at that model as well. But most of our network study is normally done with respect to the TCP/IP model, so we need to focus a little more on the TCP/IP model. So let's look at what are the 5 layers that we have in the TCP/IP model. It is pretty much the same as the example that we have been dealing with in the previous session, which is that we have a physical layer, link layer, network layer, transport layer and application layer. So let's start from the layer, the topmost layer, and see what are the actual functions that are to be done by each of these layers. So what does the application layer do? It is supposed to support networking applications. So what does it do? So you have different applications like FTP, SMTP, HTTP and so on. These are words that you must be familiar with. FTP stands for File Transfer Protocol, SMTP stands for Simple Mail Transfer Protocol, HTTP is the one that we use in our web browsers, the Hypertext Transfer Protocol. So all these are the different protocols which are used at the application layer. Now coming to the transport layer, the job of the transport layer is to ensure an end-to-end, endpoint-to-endpoint data transfer. That is, we saw that from an endpoint to another endpoint, you have a data transfer that is taking place, and whatever is required for that data transfer is handled by the transport layer. In the TCP/IP model, there are two popular protocols which are used at the transport layer, the TCP protocol and the UDP protocol. We will take a look at TCP and UDP in detail later. Right now, we just need to understand that these are two protocols which are used at the transport layer. The third is the network layer. The network layer basically does routing of data from source node to destination. Now this routing function has to be done at various places, as we saw. It has to be done at the end stations and also at all the routers in between. Now the protocols which are necessary for doing this functionality at this layer are the IP protocol, which does the actual forwarding of packets, and routing protocols which are used to find the route to go from any source to any destination. Next is the link layer. So what is the job of the link layer? We have already seen this. Link layer just ensures the data is transferred between neighboring network elements, across a link between a point and another point which are connected by just a single piece of link. Whatever data transfer has to take place, whatever needs to be done for that data transfer to take place effectively, that is done by the link layer. Examples of the link layer protocols are PPP, which is a point-to-point protocol, and you also have Ethernet, the most commonly used MAC layer that you have, the medium access layer protocol that we have, the Ethernet standard which is used. All these form part of the link layer in this particular protocol stack. The bottommost layer that we have is the physical layer. What is the job of the physical layer? It's the one which actually transmits the bits on the wire. So these are the 5 layers that we have in the internet protocol stack. Now let's just take a different look at this network structure and look at how these different layers are implemented in this entire network. So let's look at, we basically need to look at 3 different places where all the network activity takes place. One is the network edge, the other is the network core, and the other is the access networks or the physical media. So if I look at network edge, what do I mean by network edge? I am talking about the edge of a network. Edge of a network, basically we are talking about end systems. At the end systems, what is it that we are dealing with? We are dealing with applications and hosts. Network core deals with routers. The ones which are colored in yellow over here, they refer to the network core, which are basically the routers. Then we have access networks and physical media, which actually constitute the communication links. The links which are used to either access the network and also for the links which are used for transferring data from one intermediate node or one router to another router. So there are 3 different parts that you can look at with respect to the network structure. So let's just look at what we have, what is happening at the network edge. At the network edge, we said we have 2 things. One is that you have applications, we have hosts which are running applications, and then you need to make sure that data goes from the correct application to the correct application. Okay. So now when you look at end systems or hosts as we refer to them, what are they doing? Their job is to run application programs. So it may be a World Wide Web application, it may be an email application, but all these are happening at the edge of the network. Okay. And again we have different models that we talk about over here. We talk about a client server model, we talk about a peer-to-peer model. These are popular models which are used at the for applications to actually transfer data from one end system to another end system. And this we normally refer to as an L5, layer 5. If you remember, we have 5 layers and the application layer is the topmost layer, so we refer to as an L5 or layer 5 part. Okay. So next, if you look at the so you can see what is happening here. The data transfer takes place from one edge to another edge. So next, look at the network edge again, but now we are not looking just at layer 5, but you are looking at layer 4. Now layer 5 was an application to application information transfer. Layer 4 is a process to process service. So what do we mean by process to process service? What we mean here is we need to choose the right application to which the data is to be delivered. Remember that at the transport layer, you have data coming in from different applications. At the application layer, you may have different applications which are running, and all of them are giving the data to the transport layer. So what is the job of the transport layer? To identify the process to which the exact data has to be delivered. So the job of the transport layer, basically we say, is multiplexing and demultiplexing. So let's look at what we mean by this multiplexing and demultiplexing. It's very simple. What do we normally mean by a multiplexer operation? A multiplexer operation typically is you have multiple inputs and there's a single output. One of these inputs gets routed to the output. So the same thing if you look at the transport layer, you have different applications, many applications, and a single network layer below. So data is taken from different applications and multiplexed onto a single network layer below. Similarly, at the other end if you look at, you have the operation of demultiplexing. Now what does a demultiplexer normally do? It takes a single input and routes it to multiple outputs. So you have a single input coming in, going into the correct output that it has to be routed to. You can see that the same job is being done the transport layer at the receiving end. At the receiving end, the transport layer gets data from the network layer and chooses the correct application layer to which it has to deliver it. So this job of multiplexing and demultiplexing we say is the job of the layer 4 or the transport layer, and we also refer to it as the process to process service. Okay. So now that was with respect to network edge. Now this kind of summarizes what we looked at. You take data from different applications, add addressing, reliability, whatever kind of information you want to form the datagram, and send the datagram to the peer. Now the peer here is the peer at the other end. Now this receives the data and delivers it to the correct application. So the logical flow that we talked about, that and this are pretty much the same. That is, you have the transport layer which is giving you the logical connection between the two end applications. The two protocols that we talked about, I said there are two protocols that we use in the transport for the transport service in the TCP/IP network protocol stack. One is a UDP protocol and the other is a TCP protocol. Now the UDP protocol, it stands for user datagram protocol, it's also referred to as a connectionless protocol, and the job that it does is just this, the job of providing a multiplexer demultiplexing functionality that we just referred to. Now what the TCP protocol does in addition to this job of multiplexing and demultiplexing is that it provides for reliable data transfer, and it is referred to as a connection oriented protocol. Now it's very easy to quickly understand what we mean by connection oriented and connectionless. In a connection oriented protocol, you make sure first that an end-to-end connection is established before you start sending the data. This is something like your telephone connection. When you make your telephone call, the moment you pick up and dial your number, unless a call is established, unless a complete path is established to the destination, your call does not go through. You can't start talking. So you cannot deliver your data until the call first has been established. So you first establish a connection, then you start transferring data. That's a connection oriented protocol. A connectionless protocol is something similar to our postal network. Now we don't obviously set up a network to the person to whom we are trying to send a package or some letter. So what do? We just go and write a letter, you just post it in the post box, and from the post box it will take different paths, whatever, it may go through airmail or it may go through bus transport, whatever, it finally reaches the destination. You don't worry to establish a connection before you start sending the data. So that's an example of a connectionless protocol. UDP does something which is similar to that, and TCP does something which is similar to our telephone network, in that it will first establish the connection and then only start sending the data. So here, by means of doing that, it also provides you a reliable data transfer. So that in that sense, TCP is supposed to be a reliable transport protocol, whereas UDP is generally considered to be an unreliable transport protocol. Okay, so these are the two common transport protocols used in the TCP/IP model. So now let's look at the applications which typically use these two protocols, TCP protocol and the UDP protocol. Many of the common applications that we know, the HTTP protocol, which is used by the World Wide Web, the file transfer protocol, Telnet, remote login, SMTP, all these use the TCP protocol because they like to have a reliable transport being provided by the transport layer protocol. And there are other protocols like streaming media, teleconferencing, internet telephony and so on, which prefer the UDP protocol because in these cases more than the reliability that is provided by the TCP protocol, the quickness of transport which is provided by the UDP protocol is desirable. So these kind of applications, they go in for the UDP protocol. Coming to the network core, now we talked about the network edge, I am coming now to the network core. When you come to the network core, which is basically I am looking at layer 3 functionality, that is a network layer functionality, what does this actually consist of? It consists of a mesh of interconnected routers. So the fundamental question that we deal with over here is, how is data transferred through the net? So how is it the data will be transferred through the net? Basically it will have to go through the routers. So we just need to look at how that is done. Now again here we talk about two methods that are used. We refer to something called circuit switching and something called packet switching. Again, I am going to give you the same example. Circuit switching is again an example where you actually have a connection established with the other end and then the data is transferred. That is, you have a dedicated circuit which is established for the entire data transfer, so which is again similar to our telephone network. Packet switching, on the other hand, data is sent through the network in discrete chunks. That is, and the protocol that we use here are IP and routing protocols. So when you look at the TCP/IP layer as such, TCP/IP uses packet switching and not circuit switching. So the reason I am talking about circuit switching in this context is to understand that there is another way in which the switching can be done, which is circuit switching. But in TCP/IP protocol, the IP protocol uses the packet switching approach. So that is what we need to understand clearly. So in packet switching, data is just converted into discrete chunks and sent through the different routers. Okay. So next we need to look at the last two layers, the layer 1 and layer 2, which actually constitute your access networks and the physical media. So what do we have to deal with over here? How to connect end systems to the edge router. That is the job of this layer. Okay. So here we have different things like residential access networks, institutional access networks, and then mobile access networks. Residential access networks, you have technologies like dial-up modem, ADSL, and so on. Institutional access networks, we talk about access networks used by schools, companies, and so on. Typically, it is the Ethernet kind of access network that they use. Other than this, of course, we also now have the mobile access networks. 802.11 is one of the common protocols which is used on the 802.11 networks. Okay. Now, coming quickly to the OSI 7-layer model, just take a look at what we have extra in this. You have the same, if you start from the bottom, you have physical layer, link layer, network layer, transport layer, and then before the application layer comes, we have two more layers coming in between. You have something called a session layer and something called a presentation layer. So these are two additional layers which are actually present in the OSI 7-layer model. Note that we don't have these two models in our 5-layer model, which obviously means that two of these layers, that is the session layer and the presentation layer functionalities, are either taken care of in the transport layer or at the application layer in our 5-layer model. So quickly going through what we have on this 7-layer model, you can see that the bottom 4 almost are pretty much the same as what happens in the TCP/IP model. So physical layer, as we said, deals with bits, communication media, signal processing, and so on. So with these 5 layers that we looked at, L1, L2, L3, L4, and L5, you get an idea of what layering is and how it is implemented at various parts in the network. Now we will look at the OSI model in the next session, and we will just try to summarize what we have been looking at in today's session. So what we have looked at basically is what we mean by the layered approach, how the layers are distributed across various entities. We have also looked at what is meant by encapsulation and decapsulation, and we have said that there are two models, the TCP/IP model and the OSI model, and we have looked at the functionality of one of those models. The other model we will look at in the next session. Okay. So now here are a few questions that you can think of and try to answer. So what are the advantages of layering? Question number 1 for you. Question number 2, what is encapsulation? Question number 3, what are the layers missing in the TCP/IP model and what are the layers which are there in the OSI model? Which are the layers which are there in a router? And I'll give you another question where you need to do a little bit more of thinking. So let's say, for instance, I have n bytes of data being sent by an application and each layer adds h bytes of header. How many bytes are actually sent on the physical wire in the TCP/IP model? And in this case, what is the percentage of overhead which is introduced because of this addition of data, addition of the layer of the various header bytes? So these are two questions which I would like you to think about, and this, if you are able to answer this question, you would have understood the concepts that we have been looking at today. Thank you.